Welcome to Augment Yourself, a show where we dive deeper into the hottest AI topics, tools, and solutions and explore them hands-on. My name is Jan Stihec, Director of Data Science at Shelf, and I'll be your host today. A topic I want to cover in this session is Retrieval Augmented Generation, or shortly RAG. I want to cover what RAG is, how does it work, why is it important, why it is driving the adoption of large language models in the enterprise, and what are some of the challenges with Retrieval Augmented Generation. So let's jump right into it. One of the first issues, and one of the main issues we saw with large language models, is they sometimes provide inaccurate information and confidently. And if I'm dealing with a use case where I need reliable answers consistently, this is not acceptable. And one of these solutions, one of the ideas of the community was, what if we could ground large language models in a source of knowledge that we trust? And this is exactly what Retrieval Augmented Generation allows you to do. It grounds large language models in information, knowledge which we trust, which is verified, and it allows us to trace all the answers back to the information source. So now I know what knowledge is being used by the large language models to answer users' questions, and I can fix those answers in the future because I know what knowledge was used. So let's say this knowledge was not good, the answer is not good, I can fix it, I can correct it, and make sure it does not happen again in the future. So let's look at what does a Retrieval Augmented Generation pipeline look like. So on my screen, I have the main components of RAG. On the left, we see our user asking questions to the application through the interface. On the top, we can see our knowledge base, and simplified, this consists of our knowledge articles, usually documents, of a vector database where these documents or content sections are stored, and then the embedding model allowing us to vectorize this content and enable semantic search so that we can find relevant articles for a given user's query. And on the right is our large language models prompted to respond to questions only using the context that we provide. So what happens when a user presents a question to such a system? Question comes in. This question is transformed by our application, by our large language model framework, into a query. Query is sent to the retrieval system, and this retrieval system responds with relevant knowledge articles. And this is called context. This context is then injected into a prompt, and as already mentioned, this prompts the LLM to answer the question only using the found relevant knowledge articles. As an LLM response, our LLM framework takes this response and presents it to the user. So let's look at an example of using a large language model without Retrieval Augmented Generation, and then with simplified with Retrieval Augmented Generation. So I want to ask a question, and the question is about Goran Dragic, a Slovenian basketball player. So I want to know, who does Goran Dragic currently play for? So who does he play for? So ChatGPT responds with, as of my last update in January 2022, Goran Dragic was playing for the Brooklyn Nets in the NBA. Now, ChatGPT is fair. It admits that it does not know anything beyond January 2022, but I, as a user of an application, let's say this application should respond to users on questions about NBA players, statistics. As a user of this application, I would not be happy with this response, because the truth is Goran Dragic has retired in 2023, so he's not currently playing for any teams. So let's look at how we could handle this question better through a Retrieval Augmented Generation pipeline. I want to ground LLMs in verifiable, updated, sourceable knowledge. And let's say in this example, I use Wikipedia articles. Now these Wikipedia articles need to be processed. I will slightly simplify it for this demonstration, but let's say I have my Wikipedia articles in my knowledge base. A question comes in on Goran Dragic. This is transformed into a query. Who does Goran Dragic play for? I find my relevant knowledge article, which is about Goran Dragic, and then a prompt with injected context gets sent to an LLM. So let's look at what this prompt could look like in this example. I'm going to create a new conversation, and now a simple RAG prompt looks like this. Answer the question using only the provided context. So now I don't want ChatGPT to use its own internal knowledge, but I want to use the context that I will provide. So let's make sure ChatGPT understands what is context and what is our question. And let's look at this simplified example. So we have found this article as relevant for the given query, and I will just take the first paragraph of our Wikipedia page on Goran Dragic, and I will inject this into my prompt. And the question remains the same. So who does Goran Dragic currently play for? Let's see how ChatGPT responds. So Goran Dragic is a retired basketball player. He does not currently play for any team. Now this is the correct answer because we have provided information which is correct, which is updated, and my response is not correct. So again, as a user of this application, I want my answers on NBA players to be updated, and now I'm happy with this answer. So this is one of the examples where a RAG application works very well. If we need our information to extend beyond the LLM cutoffs, LLM knowledge cutoffs, because LLMs have a knowledge cutoff which depends on the last training iteration done, and they will not know, unless we do something about it, they will not know updated information. Let's say I have an application on live football scores. I want to know who won a game played yesterday. ChatGPT, out of the box, will not be able to answer. ChatGPT, through a Retrieval Augmented Generation pipeline, where I have this knowledge, where I have it indexed, present in our vector database, retrieved for a given query, and then presented to an LLM, and then an LLM respond to this query. Using this knowledge, I can have my accurate answers. Second large group of applications is when knowledge that I want used for answer generation is not present in LLM's training data. Let's say I have my own private knowledge base. This is a very common scenario in enterprises. We have our own information, we have our own documentation, and we want our employees using that information, or we want customers asking questions about our product. So this is a very common use case in retail. I want a customer support chatbot answering questions about our product, about product prices. Those are specific to our company. Those are not publicly available. Those are not available in LLM's training data. A chatbot or a LLM out of the box will not be able to answer those questions. But again, through Retrieval Augmented Generation pipeline, I can now power such applications and such use cases. So what are some of the main challenges of Retrieval Augmented Generation? So they mostly lie in the top part of our graphic, and it's in the knowledge base. I need to get to my articles relevant to a given query reliably, and that is not an easy task. So in the example I was showing, I have simplified it quite a bit, but when we have a large knowledge base, getting to accurate or getting to relevant knowledge articles is a challenge that needs to be solved. And then the second challenge is I have taken the information accuracy burden off from our LLM, and I have put it on our knowledge base, because let's see if I change just one thing in this prompt, and I will change this first sentence to say a Slovenian professional basketball player, and let's see how ChatGPT deals with that. As of the provided context, Goran Dragic current team is not specified. So this answer is probably the worst of all the three which we have seen, and the reason for it our context, our knowledge is not accurate, or it does not provide the information needed to answer this question. So this is something that we need to consider. We need to make sure, okay, now we are grounding LLMs in sourceable, verifiable knowledge, but this knowledge needs to be accurate, it needs to be updated, and it needs to be trusted. So this is something that we need to take care of before we start using retrieval augmented generation in a system which requires reliable answers consistently. And with this, I'd like to conclude this video. Retrieval augmented generation is really driving adoption of large language models in the enterprise because it allows us to ground LLMs in sourceable, verifiable knowledge, and it powers or enables some of the use cases that I've mentioned. Internal knowledge Q&A bots, external customer-facing chatbots answering questions about products. It's a very powerful technique which sees a lot of use in the field, and it's also subject of many different research papers and open source frameworks. Thank you for being with us, and we'll see you again next week.